Assalamualaikum and good day to all participants of International Symposium on Advanced Statistical Data Analysis and Operational Research 2020. My name is Shariffah Syed Jamaludin from UTM Center of Industrial and Applied Mathematics, UTM. The title of my presentation is Modeling the Changes in the El Nino Southern Oscillation Indices using Functional Data Analysis with Application to the Climate Phenomenon. This is my presentation outline. We'll start with introduction to FDA, objectives, methodology, result and discussion, and finally conclusion. So what is functional data analysis? The idea of FDA was introduced by Ramsey and Silverman in 1997. It is on the analysis of curve of function, where it represents a number of observations at discrete time interval about an individual in the form of a function or curve rather than univariate or multivariate data. It may contain more detailed information about the underlying system compared with traditional data, which consists only point observation. For example, since we already have a smoothing curve of function, we can compute the first and second derivative, which could give more detailed information. Why we use the functional approach? First, the timing intervals for data observation do not have to be equally spaced for all cases and can vary across cases. Second, there is no concern about correlations between repeated measurements since FDA treats the whole curve as a single entity. Third, FDA provides additional information on temporal aspect, and FDA also could give information on the pattern and variation of the data. For example, information on the slopes that are reflected in their derivative. FDA can be applied in climatological and environmental, geophysics and oceanology, economic, and also biology. The El Nino Southern Oscillation, or known as ENSO, is an erratic climate phenomenon that causes ocean temperature to rise in the tropical Pacific Ocean, causing unusually heavy rainfall in a few parts of the world and dry spells elsewhere. El Nino, prolonged heating of surface temperature over the eastern Pacific Ocean, where it occurs half-year period from 2 to 7 years. Where we have the term La Nina, the direct inverse of El Nino occurs when ocean surface temperatures in the central Pacific Ocean drops to lower than the typical readings. Southern Oscillation Index, or known as SOI, is an indicator of the advancement and intensity of El Nino and La Nina, where if we have positive SOI values above positive 8, it shows the La Nina phenomenon, while negative value below -8 show the El Nino event. So, our objective is to use FDA in representing the SOI pattern in the form of the smoothing curve or function over the study period. Second, to employ a functional framework such as functional principal component and functional outliers in analyzing SOI series. So, the data set that we use is Southern Oscillation Index obtained from National Oceanic and Atmospheric Administration, covers the period from 1960 to 2019. So, we have observation YI, Y1T1 up to YITT. In this case, our N is number of years, YITJ is the monthly SOI, and the discrete observed data are converted into the smoothing curve as temporal function with a base period of T and K basis function. So choice of K can be justified to capture the SOI variation. So this is the procedure to convert discrete to functional data. So first, building up a set of basis function. Second, Fourier series is employed as basis function since SOI is a seasonal series. Third, coefficient of the basis function are obtained by minimizing a least square criteria. Degree of smoothness is determined by the number of basis function. So, roughness penalty approach could be used since it offers a great control of the smoothness, where it penalizes on the second derivative. So, how we want to decide the number of basis function? So, normally, we comparing the deviance between the estimated values and observed values. Model with different number of bases are compared by considering reduction in deviance. Maximum number of bases required can be determined when there are no further bases that reduce the deviance significantly. So this is the summary statistic that we use for functional data. We have the mean curve. Instead of discrete observation, mean. Now we have a mean curve which is based on the sample curve of function. So you have x bar t 1 over n summation SIT, and then variability can be measured by using sample variance function. And lastly, we have the surface or covariance and the quantum map are used to plot the variability of the dataset. So the next method we use is functional principal component analysis. So this method extends the concept of multivariate statistics into a functional concept. So the objective is to find a new function that reveals the most important type of operation. So the procedure is replace vectors by function, matrices by compact linear operators. We replace covariant matrix by covariant operators, and then replace scalar product in vector space by scalar product in L2 space. Okay, so this is the detail of functional PCA. So we have SIT, the functional observation obtained by smoothing the also discrete observation. And then we have ZIT, which is SIT minus x bar t, the centered functional observation. So then FPCA is then applied to ZIT to create a small set of functions, where we call this one as harmonics that reveal the most important type of variation. And then the first principal component normally describe a weight function for the ZIT that exists over the same range and account for the maximum variation. And then the first principal component yields the maximum variation in the functional principal component scores, which is subject to this constraint. And then again, the next principal component are obtained by maximizing the variance of the corresponding scores. Okay. The visualization method that we use is rainbow plot. It is just a simple plot of all the data, with the only feature being a color palette based on ordering of the data set. So rainbow plot is depend on the bivariate score of the first two PCA. So this one is depends on bivariate score depth and bivariate kernel density. For outlier detection method, we use functional boxplot and also functional HDR boxplot. So functional boxplot is a bivariate boxplot is based on Tukey half space depth function. So a mapping of the boxplot of the first two robust principal component scores to the functional curve. Functional HDR is depend on bivariate kernel density estimate. So details of this method are given in Hinman and Shang in 2010. So this is the result. The smooth representation of SOI series is done with a 12-month base period, and we select K basis function. In this case, phi is chosen as the best basis function. So K equals to phi is chosen based on the quality of smoothing and high percentage of S-plane variance. So when we fit the curve, for example, we fit a smoothing curve SIT. So this is example for 1997 and 1998. We use a Fourier basis function. So this is the plot. So in the lower panel is the rate of change. So rate of change is the first derivative that we compute. So it can show us the changes that occurs in SOI throughout the years. Okay, in 1997, if you remember back in 1997 and 1998, it is El Nino phenomenon. So we can see from this plot, we have negative values starting after February until December and continue on until May 1998. Okay, which represent negative value of SOI represent El Nino phenomenon. So we use a discrete data to compute or to change into a functional data smoothing. So based on functional data, it can give you a first derivative as well as second derivative. So this is the result for statistics for FDA. So we can have a mean functional of SOI and also variation. We can look throughout the years what happened and what values instead of a discrete point observation. So the same thing, we can look at the variation in terms of quantum plot and also surface map. So this is the result for functional PCA. So we have three principal components. So it counts for 98.3% of the total variance. Based on the functional PCA, we get a component score. So this is the map of the first principal component score versus second principal component. So based on this component score, actually we can cluster it into several, we can classify it into several clusters. Okay, for example, this is a large clusters. We may consider that are having the same SOI pattern. Okay, and then for example 1982, 1983 and 1998 is still stand alone, where we can consider that one has a unique cluster. So the same thing as here in 2011, 2008 and also 1975. Okay, so based on the scores, we can classify the curve into several clusters. So how we want to represent it in terms of data visualization? So we have a rainbow plot. Okay, a rainbow plot is based on bivariate score depth and also bivariate score density. So we classify into ordering. So the first curve is the median curve, and the last curve is normally is the unusual curve, or we can consider that one as outlier. So the same thing for bivariate score density. The first curve by ordering is the model curve, and the last curve is also the most unusual curve, which is in year 1998. So if we plot a functional outliers, okay, we use here is functional and bivariate HDR box plot. So from this plot, okay, we have a 99%, okay, 99% coverage probability. We found that the outliers detected in SOI series are those curve represent 1975, 1983 and also 1998. So these years can have different magnitude and shape compared to the other observed curve. Okay, so this is functional HDR and this is bivariate HDR box plot. Okay, so same color. We have 1975, 1983 and also 1998. So on the basis of the ENSO phenomenon, these curves were related to the occurrence of El Nino and La Nina episode. Okay, if you remember, 1983, 1982 and 1983 is the El Nino, strong El Nino phenomenon. The same thing, 1997 and also 1998. Okay, while in 1975, it represents a La Nina phenomenon. So as our conclusion, the functional descriptive statistic, functional PCA, and outliers are among the FDA concepts that being introduced in the climate analysis. So based on the bivariate variance covariance surface as well as the corresponding contour give an additional insight to the climate variability than the real value or metrics in univariate and multivariate context. So in the univariate and multivariate settings, maybe the shape is not considered and cannot be captured even by using several variables. But in case of functional data, we can look at the magnitude and the shape of the curve. So overall, in general, we can conclude that the functional framework is more general and more flexible and able to make use the full information contained in the curve. With that, I thank you. Thank you for hearing my presentation.